Hey guys, today we're going to be doing the Algebra 2 Regents from August of 2025, and today we're going to be doing the part 2. In the previous video, we did the multiple choice section, part 1, so now we're going to move on to the free response section, part 2. Okay. Alright, so number 25, seniors at a high school were surveyed to see if they prefer a hoodie or a jacket for Spirit Day, and if they wanted a design on the back or the front. Survey results are summarized in the table below. Alright, so we have a two-way table here. Determine the exact probability that a randomly selected senior from the survey preferred a hoodie. So let's make that H. Given that the senior wanted a design on the back, so let's name that like B. So here we have a probability based on like something's like given. So the formula is, let me pull up. So when we have P of A given B, that is P of A and B, P of A and B over P of B. And in this case, we have P of H given B. So hoodie given back. So that means we need a P of H and B over P over B. And for this, you'll see, so the probability of hoodie and on the back, that's 45 over the total. I'm too lazy to find a total. So yeah. You can see like the total kind of like does not really matter, all over the probability over of the back. So I would have to do 45 plus 15, which is equal to 60 over the total. And then this is equal to 45 over the total times total over 65. And then this is equal to 45 over 60. You can see that the total kind of cancels out. And that would simplify into 3/4. And that is the probability. So this formula here, you would definitely have to remember for the regions. All right, sketch negative x cubed minus 7x squared plus 36 on the set of axes below, including appropriate end behaviors and zeros. All right, so for this one, you just have to graph like the general shape and then label the the zeros. So what I would recommend is, of course, graph on the calculator. This website doesn't like me a lot. Okay, so I have negative x cubed minus 7x squared and then plus 36. So for this question, it doesn't say anything about like labeling the axis. So I made a mistake somewhere. Okay, this will be a minus sign. So for this problem, it doesn't say anything about like labeling the axis. So we just need to like kind of like graph the general shape and we're good. So right now, this doesn't give us a good enough picture because I can't see everything. So I'm going to make the y min like maybe like negative 30 and then y max positive 30. And it seems like it's not tall enough. So let's make it positive, I don't know, 50. Oops, that's just 5. And then now this gives us a pretty good like idea of the graph. So we need to, it says we need the appropriate end behaviors and the zeros. So it would look something like this. Yeah, it would look something like this. And then this is consistent with the equation because this is an odd polynomial, so it's a degree 3, and if it's an odd power, then the end behaviors will point in different directions. And then since we have a leading coefficient of a negative number, the kind of like as when you go like as x approaches negative infinity, g of x would approach positive infinity, and then as x approaches negative infinity, no, as x approaches positive infinity, g of x will approach negative infinity. So you can see how like they approach different directions. Now we will have to label so we did the appropriate end behavior, now we need the zero, and this is where the calculator will come in. So I'm gonna go to graph, and I'm gonna press second, and then I'm gonna press trace for calc, and that's where we're gonna get 0. So for getting the 0, we're going to want to go a little bit left of the root. So it says left bound. We're gonna go a little bit to the left, a little bit to the right, And then we kind of like go to the middle to like guess it. So here it's at -6. So you can label -6. So this would be -6. And then here, let's do the next one. So second calc, and then we go down to 0. And repeat the process until we get the 3 roots. And that is, the next one is -3. So this is at -3. And then the last one is at I went a little too far. This, and then this, and then this. And this is at +2. So my zeros are at -6, 0, -3, 0, and then 2, 0. All right. It should suffice if you just write like -6, -3, and 2 on there, and then you have the end behaviors. You do not need to label the axis because the question didn't tell you to. All right, 27. So here we have express 8x I to the power of 10 minus 4y I to the 19th plus 2y to the 3 minus 6x I in simplest form, where I is the imaginary unit. All right, so we need to know that I is, so the square root of -1 is equal to I. So then that means -1 is equal to I squared. And we kind of like have a pattern here that you should be able to recognize. So kind of like we have the definition that these two are like the two like kind of like definitions are basically the same thing. But I'm gonna write this down here. So -1 is equal to I squared. I is just gonna equal to I to the power of 3 is equal to I squared times I, right? And then I squared is equal to -1. So this is actually -I. And then I to the power of 4th, that is equal to I squared squared. And then that's -1 squared, which would give you +1. So then we have I, -1, -I, and 1. And you will see that the cycle repeats. So when we have like I to the power of like 5, that would be I, because that's I to the 4th times I, and I to the 4th is equal to 1. And then you'll see how the pattern keeps repeating. So we have this cycle here. So first we have 8x I to the power of 10 minus 4y I to the power of 19 plus 2y I to the power of 3 minus 6x I. All right, so 8x I to the power of 10. So you know what I'm going to do? I'm going to do 10 divided by 4, which is 2, remainder 2. So remainder 2. So this one would be here. This one here, this would be like remainder 1, remainder 2, remainder 3. And this one would be like remainder like 0 or like remainder 4. Depending on how you look at it, they're like equivalent. So here we have remainder 2. So then that means this would be I squared. 10 to the power of I to the power of 10 is equal to I squared. And I squared is equal to -1. So this would actually be times -1. Okay. All right, let's see here. 4y I to the power of 19. So let's do 19 divided by 4, which would be 4 remainder 3. So remainder 3, we have -I. So this is -I. And then I cubed, that's -I. That's just that over there. And then I is by itself. So we kind of have this here. Let me move this over so I'm not confusing y'all. So this is my actual work. And then now it involves a little bit of algebra to combine like terms. So this is -8x plus 4yi, and then minus 2yi minus 6xi. We can combine the middle two together. So this becomes -8x plus 2yi minus 6xi. Alright, for the x's, we can't combine them together because -8x does not have an I, so they're not like terms. Okay, alright. A job satisfaction rate at a company is approximately normally distributed, so that's a keyword there, with a mean of 12. So that's my kind of like my mu, or you might have like x with a bar on top of 12. About 95% of the scores are between 8 and 16. What is the standard deviation of the distribution? Justify your answer. Okay, for this one, you have to remember the bell curve. the normal distribution and like the kind of like the standard deviations are involved. Let me paste a picture here so that it's a little bit easier to see. Okay, so here, this is like the graph that you're supposed to remember, the bell curve. So plus or minus 1 standard deviation. So plus or minus 1 standard deviation is plus or minus 1 SD. That's equal to 68% of the bell curve. That's the middle 68%. Plus or minus 2 standard deviation is equal to 95% of the bell curve. And then plus or minus 3 standard deviation is 90, what is it? 90, it's 90 something percent. I forgot. It's like 99%. Yeah. It's 99% of it. So we kind of like have this distribution here. And this one is actually the like, it kind of like goes into like decimal. It's more like 99.7. So yeah. And if you're interested in like AP statistics, then you will learn a lot more about the bell curve. All right, so we know that about 95% of the scores are between 8 and 16. That means we have 2 standard deviations here. So 95%, that implies that it's within 2 standard deviations. So it's a mean. So the mean is 12. And then 12 plus or minus 4 gives you 8 and 16. So that means 2 standard deviation is equal to 4. That means 1 standard deviation is equal to 2. So yeah, that's how you would solve it. And yeah. Okay. An angle theta is drawn in standard position and terminates in quadrant 3. So we have that. Given that cosine theta is equal to negative root 10 over 10, determine the value of tangent theta. So let's draw it out. I like drawing out. So in quadrant 1, 2, 3, and 4. There's going to be somewhere over here because it's in quadrant 3. And we want the value of theta. So if you remember, all takes calculus. That's like kind of like the mnemonic I like to remember. In quadrant 1, all of the trig functions are positive. In quadrant 2, sine is, and in quadrant 3, tangent is, and then in the last quadrant, cosine is. So in this case, tangent of theta is positive. Tangent of theta is positive because theta, the angle, it terminates in quadrant 3. All right, so then now we have to find the value of tangent. So what you have to do is apply a little bit of right triangle, just like right triangle stuff. So cosine, remember cosine theta is equal to adjacent over hypotenuse. So that's coming from SOHCAHTOA. And we learned that from right triangle trigonometry. And then now that we have this kind of like coordinate plane, it kind of like it's the right triangle stuff on steroids. We also have signs now, plus or minus. So adjacent, so this is going to be my angle. Well, I'm going to actually use alpha because this is my reference angle. And then adjacent, negative 10. So this is negative root 10. And then my hypotenuse is going to be 10. I want to find out what this side is. And we have a right triangle here, so we can just use the Pythagorean theorem. So we have a squared plus b squared is equal to c squared. So then that means root 10 squared plus b squared is equal to 10 squared. And then this would be 100, and then this would be 10. So then b squared is equal to 90. So then b is equal to root 90, which we can simplify to 3 root 10, right? Because this is root 9 times root 10, and root 9 is equal to 3. So then my b is equal to root 10, and then now we can find tangent. So recall tangent of theta is equal to opposite over adjacent. So opposite. Oh, this will be negative, by the way. I'm going like downwards, going down. So this will give me like the length from using the Pythagorean theorem. I'll get the length, but this has to be negative. I forgot to put that there, but just remember that it will be negative. It makes sense because this distance here I'm going down from the horizontal axis. So tangent of theta is equal to opposite over adjacent. So opposite to the angle, we have negative 3 root 10. and then adjacent, we have negative root 10. So then that means tangent of theta is equal to 3. Okay, algebraically solve for the value of x. So here we have an equation, and it's involving a radicals, and if it has a radical, we know that whatever's inside here has to be greater than or equal to 0, or else we can have extraneous solutions. Or you can, like, after you solve this equation, you can plug in and check. So for this one, we know that this cannot be like whatever's underneath the radicand has to be greater than or equal to 0. So x plus 5 must be greater than or equal to 0. So x must be greater than or equal to negative 5. So that's because we can't take the square root of negative numbers. So that's because here we're dealing with real numbers. So for this equation, what I'm going to do first is I have that square root, and that's like the main thing that's bothering me. But before I do anything to the square root, I'm just going to add x on both sides so that I can isolate the square root. Now that the square root is by itself, what I'm going to do is I'm going to square both sides so I can get rid of that square root. So when I square it, this kind of just cancels out with itself. So this is just x plus 5. And then the right hand side, we just have a standard like square expansion, and this is pretty easy. And then to solve a quadratic, I'm going to set it equal to 0. So this becomes plus 5x plus 4. Yep. And then I'm going to factor this. So I want to find two numbers and multiply to 4 and add up to 5. Pretty easy. It's 1 and 4. So then we have 0 is equal to x plus 1 and x plus 5. And then now to solve, set each of them equal to 0. So x is equal to negative 1 and x is equal to negative 5. And then we can plug in. Oh wait, no, this is not 5. This is minus 4. Wait, no. Shoot. 1 and plus 4. Okay. All right. For this, I'm gonna plug back in and check. So these are the two x values that I have. I'll plug in check. So for x is equal to negative 1 plus 5 minus x. So then negative 1 plus 5 minus negative 1 is equal to 3. So then this is 4 plus 1 is equal to 3. 2 plus 1 is equal to 3. 3 is equal to 3. And this is indeed true. Alright, I'm actually going to put question marks here so that I'm indicating that I'm checking this. Alright, now for negative 4, I'm going to have the original equation down. And then I'm going to plug in negative 4 here. Minus negative 4 is equal to 3. And then this is 1 plus 4 is equal to 3. And this shows that 5 is not equal to 3. So this is in fact not true. So we're going to reject this. We're going to reject, but we're going to accept this. So our solution is just x equals negative 1. So I mentioned this in the first place because no matter what we get down here, this has to be greater than or equal to negative 5, or else we whatever is underneath the whatever is in the the square root part is not going to work. But then after we do get the answer, we still got to plug it back in and check in case there's an extraneous solution, which is the case with x is equal to negative 4 there. What I would recommend you to do, you can kind of skip this step, but this step is just letting you know one of the domain restrictions. Okay, use the geometric series formula to determine the 30 years earnings for an employee whose first year salary is $42,000, earns an annual raise of 3% rounded to the nearest $1,000. Okay, so we have the initial value. I'm gonna put a sub 1. So that's their starting salary, which is $42,000, and then we have an annual raise of 3%. That means this is a growth So that means my R is going to be greater than 1, and it's 3%. So it's going to be 1 plus 0 0.03, and that's equal to 1.03. R, I would do 1 plus 0 0.03. 0 0.03 is 3% in decimal form. So this is my R. 0.03. And then for this, we have the formula for the sum of a geometric series is right here. You don't have to remember it. Just know that you have these formulas here. Make sure you know how to use them. So we have S of n is equal to a sub 1. So that's my first value minus the first value times r to the n. So n is 30 years. So n is to the power of 30. Or actually my r is 1.03 to the power of 30. And then all over 1 minus the ratio, which is 1.03. All right, plug this into your calculator, and you should get 190. What is it? 1998000. Yeah, and you get a little bit of a decimal, but it says rounded to the nearest $1,000. So that would be it rounded. On your calculator, you should get like 1998167.46, something along the lines of that, and it says to round to the nearest $100,000. Not near nearest $1,000. Okay. Algebraically determine the solutions to the equation 2x squared equals 2x minus 1 in simplest a plus bi form. All right, so if it says to algebraically determine this and it says to put it in a plus bi form, that means we're probably getting complex solutions. Complex solutions. If the solutions are complex, then chances are we cannot factor, and we will have to use the quadratic formula, which works for any quadratic equation. It's just that it's going to be a little bit tough solving for it. So first, in order to put it into we're gonna first, we have this equation over here. We can't use the quadratic equation yet because this is not in the quadratic formula yet, because this is not in the form. So we have to make it equal to 0. So we have to put in the standard form first. So I get this. And then here we have, this is my A, this is my B, and this is my C. And if you remember the quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. You have to remember that. I don't know if it's actually on the thing. Oh, you do have the quadratic formula. All right, it's great, but I'm not sure if they're going to remove it one day. But yeah, you have that formula, and then you plug it in. So x is equal to negative b, which is negative 2, plus or minus b squared, which is negative 2 squared, minus 4a, which is 2, c is 1, and all over 2 times a, which is 2. So x is equal to 2 plus or minus 4 minus 8, all over 4. So then you have x is equal to 2 plus or minus root negative 4 all over 4. This is equal to 2 plus or minus 2i, because this over here, that's square root of negative 1 times square root of 4. Square root of negative 1 by definition is going to be I, and the square root of 4 is 2. So this is 2i. And then all divided by 4. So then x is equal to 1 plus or minus I over 2. So this is in simplest form. So we have two solutions. So x1 is going to be 1/2 plus or minus 1/2 I plus, and then my other one is going to be 1/2 minus 1/2 I. And I think you can combine those two things, but if it's separate, it's just a little bit better. But it both works. Okay. All right. The GDP per capita measures worldwide economic output per person. The GDP per capita Y in dollars, X years after 1990 is listed in the table below. Based on the data, write an exponential regression equation to model the GDP per capita in dollars X years after 1990. Round all coefficients to the nearest hundreds. All right. for this one, what we're going to do is we are going to use a calculator and we're going to use the regression functions. So I'm going to quit this. All right, so I'm going to go to stat and I'm going to edit so I can input the data. So my x is going to be an L1. So I'm going to put 1, 6, 18, 25, and 29. So I have 1, 2, 3, 4, 5 values. 1, 2, 3, 4, 5. Okay, that's it. And we have 9, 6, 8, 0. 1, 0, 2, 1, 13, 7, 1, 3, 1, 5, 5, 5, 2, 16, 9, 7, 6. Okay, let me just double check that the numbers are correct. Always double check that whatever you type in is correct. I feel like I always make that mistake. Okay, we're gonna go to stat and we're gonna calc, and then we're gonna scroll down to reg. So this is exponential regression. And we press enter. X is going to be L1, Y is going to be L2. We don't have a frequency list, so don't worry about that. So just go down to calculator. Now, the equation they're going to give us in y equals a times bx, and then our a is it says round to the nearest hundred, so a is 9290.57. No, 9290, yeah. And then b is 1.02. So that means my equation is going to be 9290.57 times 1.02 to the power of x. Okay. Use a rounded equation for model A to algebraically determine to the nearest tenth of a year the number of years after 1990 when a GDP per capita was 15,000. All right, so we have this equation. We have 15,000. It's going to equal to the equation that we set up here, which is 9290.57 times 1.02 to the power of x. All right, first what we're going to do is we're going to divide both sides by 9290.57. 9290.57, and then we have this over here. I'm not gonna really simplify this because I am a little bit lazy. It's equal to 1.02 to the power of x, and then to get this by itself, like to bring x down, I'll have to use log. Then we log in the base as this. In this case, x would be bring down, and then log base of something to the same thing is like it's gonna cancel out. It's gonna be 1. So that means log base 1.02 of 15,000 over 9290.57. So this side is just gonna equal to x. And now here, you wanna plug that into your calculator. If you need a little reminder how to get the log base something, you can either use change of base, which is like log of something over log of something, like the base. Or I like to just go to the calculator. I think like on the TI-84 you can do it, but on the TI-83 you might not be able to. Log base 1.02 of 15,000 over 9290.57. And then once you plug it in, you get x is equal to, it's just round to the nearest tenth, so it's 24.2 years. So yeah. Okay. Consider the function below is x plus 3 a factor of L of x. Justify your answer. Okay, so there's two ways that you can do it. You can either you can either you can do like a little bit of polynomial division, or you can use the remainder theorem. So I think for this one, I'm going to just try to divide it out. So I'm going to use synthetic division actually. So in order to do synthetic division, what we're going to do is that we have an x plus 3. We just got to set that equal to 0. There's nothing in front of the x, and x is like x plus 3. This is the linear term. X is to the power of 1. This makes polynomial, it makes synthetic division so easy. So x is equal to -3. So -3 goes here. And now I'm going to write the coefficients. So if any of the powers are skipped, I'm going to use a 0 as a placeholder. But that's not the case here. So we're just going to write this. So we bring down the first one, which is just 1. And then I'll have to multiply. So this becomes -3. So 1 times -3 is -3. And then I add again. This is 0. 0 times -3 is 0. And then I add those two, -3 plus 0, which is -2. -2 times -3, that's 6, and then when it adds, it's 0. So 0 is going to be my remainder. So here, the remainder is 0. So that means f of x can be written as x plus 3 times x squared minus 2, because this is my like x squared. It's going to decrease by 1 power. So this is x to the power of 3. It's going to decrease to x squared. And then we have this. And then, yeah. So then, yes, x plus 3 is a factor. We showed it by division. And there's a remainder of 0. So remainder of 0, that's another way that you can say it. Now determine all the zeros of f of x. So notice how I kind of like peeked ahead and said that, and saw that it asked for the zeros of f of x. So that's why I did the factoring, like did the division, because if it divides, and I kind of like have it like kind of like somewhat factored already, and it would make solving a lot easier. So we have, if we're looking for the zeros, we're going to set the equation equal to 0. So we have x plus 3 times x squared minus 2 equals 0. So that means x plus 3 is equal to 0. So x is equal to negative 3. That's 1, 0. And then x squared minus 2, that's equal to 0. So x squared is equal to 2. And then to solve that, I would do x is equal to plus or minus square root of 2. Because I'm taking the square root of both sides. But remember, if we're taking the square root of both sides, we need a plus or minus. So those are our 3 zeros there. Okay. Algebraically solve the system below. For this one, what I'm going to do is we're going to use elimination to do it. Okay, so let's see. Let's try to solve for, let's see the first 2 equations. So I'm going to label the equations 1, 2, and 3. So we have, I'm going to do 1 plus 3. So I get 2a plus b minus c equals negative 4. I have negative 2a, negative 2a, minus 3b plus 2c is equal to 11. So I'm going to add those 2 up, and you'll see why I did that. These 2 cancels out. So then this becomes negative 2b plus c is equal to 7. Okay, let's hope that I'm doing this right. And then I'm gonna do 2 minus equation 2 minus 2 times equation 1, and this way I can eliminate a again. So I get so 4a plus b plus c is equal to 3, and then 2 times the first equation, that's gonna be 4a plus 2b minus 2c equals negative 8. And you see I did that because I can eliminate this again. And notice how I'm subtracting the 2 equations now. So then this b minus 2b, that's negative b, c minus negative 2c, that's 3c, and 3 minus negative 8 is 11. So then I have those 2 equations, and I think I'm going to solve for, this is equation 4, and this is equation 5. Okay, now I can use those 2 equations to solve for B and C. So you know what I'm gonna do? I'm gonna do 4 minus 2, equation 4 minus 2 times equation 5. So this is equation 4, 2b plus c is equal to 7, and then 2 times equation 5, that's gonna be negative 2b plus 6c is equal to 22. And then when I subtract, I get c minus, so this is negative 15. Negative 15. So c is equal to 3. So boom, I got that. Then now I can just plug it back into either equation 4 or 5 to solve for b. I'm going to plug it back into equation 5. That's negative 3 plus 3c is equal to 11. So negative b plus 3 times 3 is equal to 11. So negative b plus 9 is equal to 11. Negative b is equal to 2. So b is equal to negative 2. So I got b. And now I just gotta plug it into one of the equations. I'm just gonna use equation 1. 2a plus b minus c is equal to -4. 2a plus b, which I solve, is -2, minus c, which is solved, is 3, is equal to -4. 2a plus this is minus 5 is equal to -4. So 2a is equal to 1. So a is equal to 1/2. And that's it. Alright. Solving these like systems of like 3 linear equations, it's a lot of work. Just remember, you are just trying to eliminate. That's the main method that you should use. And for this one, I would always recommend checking it with a calculator. You can do that with if I remember, this has been a while since I did matrices. Okay, I'm gonna edit it, and I'm gonna make this a 3/4. So this is 2, 2, 1, -1, -4, 4, 1, 1, 3, then -2, -3, 2, and 11. And then I'm gonna go to math. No, not math. Matrix. I'm gonna go math, and then I'm gonna do RF, and then oops, sorry. I'm gonna quit first. I'm gonna go to matrix. Then I'm gonna go to math, and then I'm gonna go to RF, and then I'm gonna go, and you will see. So the first row is gonna give me my A, which is 0.5. Okay, I got 1/2. That works. And then my second row, that's B. That's -2. Exactly what I got. And then C, that's 3. Also what I got. So this is using matrices to solve it. You might learn about how to use that in like this is like the reduced row echelon form, and you're gonna learn about it in pre-calculus maybe. But yeah, that's how you check it. On the newer calculators, you have the math. Actually, you have is it under maps? Okay, you have program apps. No, okay, not on this calculator. Yeah, not on this calculator. On some calculator, let me see if the actual online one that I can use on my computer, if they got it, because on the newer calculators there is a built-in function that allows you to do it. Let me just check real quick. They do have it. So if you go to press applications, and then you go down to number 7, it's like PLYSMLT2. So that's like polynomial, like simultaneous equations. You go to number 2, simultaneous equation solver, and you have 3 equations, 3 unknowns, and then you would press next, and then you would get like this screen. Let me take a screenshot. I wish I can show it to you guys here, but I'm not gonna really show you guys this much because this one is not on all calculators. But if you have the newer calculators, just know that this is a function that might be built into your calculator. If it's not, then I would check using the matrix, using the reduced row echelon form. But yeah, okay. Let's look at number 36. We have given f of x is equal to 5x squared plus 3x minus 12, and g of x is equal to 2x minus 1. Express 4 times g of x minus f of x plus 1 as a polynomial in standard form. Okay, so we have 4 of g of x. Whoopsies. Okay, we have 4 of g of x. So that means it's going to be equal to 4 times g of x, which is 2x minus 1, which is equal to 8x minus 4. Okay, and then we have f of x plus 1. That's equal to 5 of x plus 1. X plus 1 squared plus 3 times x plus 1 minus 12. So notice how I'm just plugging in x plus 1 into x into the original function here. That's what that means here. So this is equal to 5 times x squared plus 2x plus 1 plus 3x plus 3 minus 12. So this is equal to 5x squared plus 10x plus 5 plus 3x plus 3 minus 12, which is equal to 5x squared plus 13x plus minus 4. I hope. Okay, so now for g of x minus f of x plus 1, that's 8x minus 4 minus 5x squared plus 13x minus 4. Sorry, minus. That would be 5x squared minus 5x. That's it, because the 4's cancel out. Okay, that's your final answer. Okay, part 4, we have this. The height and field that ties along coastline can be measured by waters oscillating between low tide and high tide. So if we have the word oscillating, that means it's going to be jumping up and down, up and down. And that should be a hint that we are dealing with a sinusoidal function. So like sine or cosine, I believe. And yeah. Okay. In Daytona Beach, T hours after midnight in July. So we are given an axis. Okay. State the period B of t in hours. So the period, that's going to be the length of one cycle. So the length of one cycle. So you can do from peak to peak, or from kind of like the so min to min or max to max. So I think it would be easier to do from min to min, because this is just 12. So that means my period is going to be 12. Let me be consistent with my color. Period is going to be 12, and you can even state it. Well, it gives you the units hours. Write an equation for b of t in the form b of t is equal to a cosine bt plus c. All right, so I have to be able to recognize the part. So a is going to be my amplitude. B, that's a frequency. My absolute value of A is the amplitude. B is the frequency. And the formula you have to remember is that the period times the frequency is going to equal to 2 pi. And then C, that's going to be like my midline. C is going to be like my midline. So here, A is going to be it's going to be the average between the max and the min. So so from here, 1, 2, 3, 4, 5. So my A, absolute value of A is going to be 5 over 2. You take the average of the max and the min, and that's like the middle value. So that's kind of like my midline here. My midline would be like right here. So that would be like my C value. Not my C, my A. Absolute value of A is going to equal to 5 over 2, I think. 5 over 2, yeah. Okay. My B, so my period is 12, and we know that B times P has to equal to 2 pi, so B times 12 is equal to 2 pi, and if I solve for B is equal to pi over 6. And then my C, well, my C, it's going to be same thing as my C is my midline. Oops. Oh, okay, I kind of messed. Okay, so in this case, my midline is the same thing as my amplitude, because the minimum is at 0. So that's why what I did work, because I took the average of this, which is 0, and then this is 5. So when I averaged the distance, when I did the when I take the average, I would get the midline. So if I do 5 plus 0 divided by 2, that would give me the midline. But if I do the subtraction, 5 minus 0, that would give me the amplitude, which is going to be the same thing. So my B is pi over 6. My C is going to be equal to 5 over 2. So now A, notice how I said that the absolute value of A is the amplitude. So the sign of A matters. In this case, my A would be negative because I start at the bottom. So for a typical cosine graph, it starts at the top. It goes like this, like that. It starts at 1. But then since I start at the bottom, I start at the mid, I will use negative. So that means B of t is going to equal to negative 5 over 2 cosine of B, which I solved to be pi over 6 t plus 5 over 2. So that is the equation. In Derby, Australia, the height of the tide and feet can be modeled by the function d of t equals 8 cosine pi over 6t plus 16.5. On the grid provided on the previous page, graph y equals d of t on the domain 0 is less than or equal to t, which is also less than or equal to 24. Okay, so let's break down the value. My A, my amplitude, is going to be equal to 8. My P, my period, actually no, my B is pi over 6. So that would mean that my period is equal to 12. We have the same frequency from before, so that the period will have to be the same. If not, then you can resort back to this equation, this kind of like rule to solve for the period. And then my C, which is my midline, is gonna be 16.5. That would give me the midline. So we can graph it here. So the midline is at 16.5. I like to do it like this. So my period is 12. So I should be graphing 2 cycles. So 16.5. 1, 2, 3, 4, 5. So 16.5 would be like right over here. That's gonna be my like midline. So I'm gonna go from, so since I have a cosine and it's positive 8, so I'm gonna start from the top. So I'm gonna go above, so it's gonna be 16.5 plus or minus 8. That's gonna be my range. So my range is gonna be from 20, wait, no, plus or minus, no, yeah, plus or minus 8. It's gonna be from 20, it's gonna be from 24.5. Well, I'm gonna do minus first. It's gonna go from 8.5 to 24.5. So my function is going to jump from, it's going to start at the top because I have a positive 8. So I'm going to go from 24.5, which is like right here, and then go jump down to the midline. So actually we have 4 regions here. We're going to divide into 4 regions. So it's every 3. So it's from like, here's one region, and then here's one region, and then here is one region. Okay, so I'm going to jump it down to down here, and then I'm gonna jump down to 8.5, which is right here, and I'm gonna jump back up, and then I'm gonna jump back up here. So that's one cycle. And notice how I divided up the period into 4 interval so that I could get like 1, 2, 3, 4, 5 points here. And that's one cycle. And then you will repeat. So I'll go like, that's an interval, this is an interval, and then this is an interval, and then like we have like the one last thing here. So we're gonna start from the top, and then we're gonna go down to the midline, and then we're gonna go down to the min here, and make sure you have like a little bit of curve to it, because this is a cosine graph. It's not supposed to be like straight. So notice how like towards like the mins and the maxes, I like to curve it a little bit. That's where the curving is a little bit more obvious. And then we jump back up to the, and yeah. Okay, state in feet of the low tide, we kind of like have it here. That's my low tide, it's 8.5 feet. It's just the midline minus the amplitude. And the midline is 16.5 minus 8 is 8.5. All right, that's it for the test. Hope it helps you guys with the studying.